Hello everyone, and welcome to part 3 of our intermediate webinar series, Making Figures with ggplot2, Axes and Labels. In this section, we're going to review how to customize the axes and labels of your figures using ggplot2. For our example data, we will be using the same assembly QC table from the previous section, which was made using Quast, and we're going to read it into the variable df using the read.delim function. First, we're going to go over axes and titles, and you may have noticed that by default, ggplot2 labels the x and y axis using their respective column names. Additionally, a plot has no title by default. So let's go ahead and load in the ggplot2 library, and then we're going to plot our data with the x-axis equal to species and the y-axis equal to total length, and we're going to plot a box plot with no outliers present. Now here we see that by default, let's go ahead and just take a quick look at the data, that the total length here, which has a capital T and a lowercase l, is on the y-axis, and species, which is capitalized, is on the x-axis, and they are the same as the column names. Now we can change those defaults using the xlab and ylab functions. So just as we add the geom_boxplot function to our base ggplot function, we add the xlab function with the ylab function as well. And I am going to set assembly species as the x label and assembly length in base pairs as the y label. And now here, as you can see, we have a changed y-axis and a changed x-axis. Alternatively, we can use the labs function, and we can set the x parameter equal to whatever we want the x label to be, our y parameter equal to whatever we want our y label to be, and then we also can change the title here by setting title equal to whatever we want the title to be. So let's run that code, and we see here that the x and y labels are changed, and we have also added our title. So ggplot2 will automatically choose a limit, scale, and label for our axes, but we can change those defaults as well. The xlim and ylim functions can be used to change the limit of an axis. These are the highest x and y values of the total length that we had in our line graph all the way back in section 1. So we're going to go ahead and choose values close to those as our x and y max, and our x and y min will be 0. So this is what the base plot looks like using all of ggplot2's defaults, and this is what it looks like with our chosen x and y limits. And they look pretty similar. Even at first glance, it's almost very difficult to see unless you go back and forth between the two. To highlight a more drastic example, let's set our x minimum to -1 million and our y maximum to +20 million. And that gives us much more space in the upper left quadrant of our plot and shrinks our plot way down because we've drastically changed those limits. Now, to change the scale of our axis, there are many functions we can use to do that are named scale_x and scale y. And let's go ahead and use the help.search function to find these and see what options are available for us. We see here that there's scale x continuous and scale x discrete. Any functions for discrete variable scaling include the word discrete, and any functions for continuous variable scaling include the word continuous with them. The limits, breaks, labels, and names of each axis can be set with those corresponding parameters. Limits are what we want our x or y limits to be. Breaks are the axis breaks we want to include. Labels are what we actually want those x-axis breaks to be labeled as on the plot. And the name is what we want the label to be for that particular axis. Let's go ahead and set our x and y limits to these corresponding values, and let's set the axis breaks to 4 evenly spaced breaks between those x and y limits. And we're going to name the labels after what the breaks are named directly numerically. And we're going to set our x name to largest contiguous in base pairs and our y name to assembly length in base pairs. This is what this looks like when we run this. Very similar to our previous plot. And we can see that we have the corresponding axis breaks for both our y-axis and our x-axis. If we were to get rid of the labels line in both of those, because our labels are the same as our breaks, nothing would change. But if we wanted to set, we'll say, some nonsensical labels, such as A, B, C, and D, we could do that. And ggplot would change our axis breaks to those values. Now, obviously, we don't want to do this in this example because we are numerically representing the breaks in the axis of a line plot, but that functionality is there. And sometimes you do want to change the names of your axis breaks. So instead of manually typing out the axis scales as we did in this example, sometimes it's just easier to manually type the scales, but sometimes you have a large axis and you want to change the default scale of it. We can use the seek.int function to create it and store it as a variable. So here I'm going to store my xmin, xmax, and ymin and ymax in variables named accordingly. And then we're going to store this scale into a variable called xscale and yscale. So we're going to use the seek.int function. We're going to put our xmin first and then our xmax, and then we set the by parameter. And for this parameter, we're just going to do xmax divided by 4, because remember, we wanted our breaks to be 4 discrete intervals of equal length. And we're going to do the same for the y scale, where we have our ymin, our ymax, and then we have our ymax divided by 4 is the by parameter. So let's go ahead and load those variables in. And then we're going to take a look at our x scale. And as you can see, these are the 4 breaks we gave it in the previous example manually for both the x and y axis. So then we can go back to our code where we included scale x continuous and scale y continuous. We can set our limits equal to a vector containing our xmin, xmax, and ymin and ymax. We can set our breaks equal to x scale and our labels equal to x scale as well as y scale. And we can keep the names we had for both the x and y axis as well. And as you can see, this is identical to the previous graph. We just gave the scales and the mins and maxes as variables rather than numbers we typed out. So there are many other functions we can use to transform our continuous axes. And for example, we can reverse our axes if you wanted to reverse either the x or y axis. And to do that, we use scale x reverse and scale y reverse. And now our graph is flipped on the horizontal and vertical axis. We can also log transform them, because when you have very large axes, it's sometimes better to scale them, especially depending on how you're wanting to represent your data. So let's go ahead for our line plot and use scale x log 10 and scale y log 10. And now ggplot has automatically log transformed our graph. And we can also log transform our axes using scale x and y continuous using the trans parameter. So we can use the scale x continuous and scale y continuous function again, and then there is this trans parameter, and let's go ahead and set that to log 10. And as you can see, it is identical to the last log 10 transformation we did, but we could also say log 2 if we wanted to log base 2 scale this. And now our graph is scaled via the log base 2. And as a reminder, you can view the other axis scale functions using the help.search function, or we can go back to the help tab and manually search it that way. So scaling discrete axes is slightly different, but uses the same parameters. So as a reminder, this is what our data looks like when we plot a box plot of species by total length without the outliers present. So we can change the name of the axis, tick marks, and order of our data. And we do that using the breaks, limits, and labels parameters of scale x discrete. So the breaks we want to change are Acinetobacter baumannii and Klebsiella pneumoniae, which are our species. The limits we want to put are Klebsiella pneumoniae and Acinetobacter baumannii. And this is different because we don't have an xmin or an xmax. We just have our discrete variables, which is the species. So instead of having the Acinetobacter baumannii samples on the left and the Klebsiella pneumoniae samples on the right, we're going to reverse that. And we do that by having Klebsiella pneumoniae first and Acinetobacter baumannii second in the vector that we give limits. And then we say that we want our labels to be named A. baumannii and K. pneumoniae. So let's go ahead and graph that. And now our K. pneumoniae samples are on the left and our A. baumannii samples are on the right, unlike in the default plot. Now, an important thing to point out. Make sure your breaks and your labels correspond to one another before the limit change. And what I mean by that is, if we were to say make the limits and labels identical, where we had K. pneumoniae on the left and A. baumannii on the right for the labels parameter, we now have our Klebsiella pneumoniae samples labeled as A. baumannii and our Acinetobacter baumannii samples labeled as K. pneumoniae. So remember, your breaks and your labels must align, and then you change your limits for how you want your data to be ordered. Otherwise, your data will be labeled incorrectly, and you don't want that. So make sure your breaks and labels align with one another. Now, to choose what variables you want to display, you can change the limits and labels. R will throw an error if you do not have the same vector length for limits and labels. So if you only want to show one part of your box plot, let's say our Acinetobacter baumannii in our case, we set limits equal to Acinetobacter baumannii and labels equal to A. baumannii. And now our K. pneumoniae samples are removed from the box plot, and we only have our A. baumannii present, labeled as A. baumannii instead of Acinetobacter baumannii. Now that's it for this section on axes and titles. In the next section, we're going to go over how to customize themes. Thank you so much for listening, and I will see you in the next episode.